Case study, Fortifying Cybersecurity Defenses Through Advanced NLP Techniques, a case study of TechSecure Inc. Organizations rely on natural language processing techniques like text classification and clustering to bolster their cybersecurity measures. Picture a cybersecurity operations center at TechSecure Inc., where a team of engineers and data scientists work tirelessly to protect the company's vast network infrastructure. Among them are Alice, a data scientist, and Bob, a cybersecurity analyst, who collaborate on a critical project aimed at enhancing the company's threat detection capabilities using advanced NLP techniques. The project kicks off with a specific challenge. TechSecure Inc. has been experiencing an uptick in phishing emails bypassing their current spam filters. Bob collects a large dataset of emails, both legitimate and phishing, to be used for training a text classification model. Alice begins by pre-processing the textual data, applying tokenization to split the text into individual tokens and using stemming and lemmatization to reduce tokens to their root forms. Throughout this pre-processing phase, Alice asks, what are the advantages of stemming and lemmatization in text pre-processing? These steps help normalize the text, reducing redundancy and improving the quality of the subsequent feature extraction. Alice opts for term frequency inverse document frequency for feature extraction. TF-IDF calculates the importance of a word in a document relative to its occurrence in the entire dataset. She explains to Bob, TF-IDF helps us to identify the most pertinent terms in distinguishing between phishing and legitimate emails. After extracting these features, Alice trains a support vector machine model on the labeled email dataset. The model learns to associate specific patterns in the text with the labels phishing or legitimate. Alice evaluates the model using accuracy, precision, recall, and F1 score metrics. The SVM classifier, boosted by TF-IDF features, shows impressive accuracy, but Alice ponders, how can we ensure the model generalizes well to unseen data? The team decides to test the model on a separate validation set, ensuring it maintains high performance with new emails. This step is crucial to avoid overfitting, where the model performs well on training data but poorly on new, unseen data. With the classifier successfully deployed, TechSecure Inc. observes a significant reduction in phishing emails reaching employees' inboxes. However, Bob notices an unusual pattern in the security logs, indicating a potential security breach. He turns to text clustering to gain deeper insights. Bob collects security logs and applies pre-processing steps similar to those used for the classification model. He asks, what might be the benefits of clustering these security logs? Bob selects the k-means clustering algorithm, initializing it with a predetermined number of clusters. The algorithm partitions the logs into clusters with similar logs grouped together. Bob is keen to explore, how can clustering help us identify anomalous activities in security logs? By examining clusters with higher intracluster similarity and lower intercluster similarity, Bob identifies a cluster of logs that stands out, suggesting unusual activity patterns. To assess the quality of these clusters, Bob employs the Silhouette score and Davies-Bouldin index. These metrics confirm that the clusters are well-formed, supporting the hypothesis of a potential security breach. Bob and Alice delve deeper into the anomalous cluster, discovering that it contains logs related to unauthorized access attempts. This revelation prompts immediate action to mitigate the threat, reinforcing the importance of clustering in anomaly detection. Combining their classification and clustering models, Alice and Bob explore a hybrid approach. Alice suggests, what if we use clustering to label data for training our classification model? They use clustering to label previously unlabeled data, which then serves as additional training data for the classifier. This strategy enhances the model's performance and adaptability, creating a robust system capable of handling evolving cyber threats. While the integrated models deliver impressive results, the team acknowledges the need for continuous improvement. Alice reflects, how can we maintain the efficacy of our models as cyber threats evolve? They implement automated feedback loops, allowing the models to learn from new data and adjust their predictions in real time. This adaptive learning is essential to keep pace with the dynamic threat landscape. TechSecure Inc. also explores the potential of deep learning techniques to further refine their cybersecurity measures. Alice experiments with convolutional neural networks and long short-term memory networks. She trains a CNN to analyze the text content of web pages, detecting malicious URLs with higher accuracy than traditional models. Bob is intrigued. What makes CNNs particularly effective for text-based cybersecurity tasks? They also find success with LSTM networks in classifying malware based on code analysis. LSTM's ability to capture complex patterns in sequential data proves invaluable in identifying new and evolving malware threats. Alice and Bob appreciate the power of deep learning, though they recognize the considerable computational resources and expertise required for implementation. Reflecting on their journey, Alice and Bob realize the profound impact of integrating text classification and clustering techniques in their cybersecurity arsenal. These methodologies have automated the analysis of vast amounts of textual data, significantly enhancing threat detection and response capabilities. They recognize the importance of high-quality data, careful algorithm selection, and continuous monitoring to maintain the efficiency and accuracy of their models. Alice concludes, "What lessons have we learned from applying these NLP techniques in our cybersecurity framework?" They acknowledge the necessity of robust feature extraction, the value of unsupervised learning for exploratory analysis, and the benefits of hybrid approaches in leveraging the strengths of multiple techniques. The case study of TechSecure Inc. exemplifies the transformative potential of NLP in cybersecurity, highlighting the ongoing advancements in machine learning and deep learning that continue to shape this critical field. Through their meticulous application of text classification and clustering, Alice and Bob have fortified TechSecure Inc.'s defenses against cyber threats. Their work underscores the essential role of NLP in modern cybersecurity, paving the way for more resilient and adaptive security protocols in an ever-evolving digital landscape.